Now our last topic is protocol translation. Here is the issue. We may decide for our mobile app to have well-defined, specifically tailored REST interfaces over standard HTTP to our API gateway, and that's terrific. However, our back-end services may not be based on these protocols. It's nice if they are, but we might need to interact with asynchronous messaging protocols like JMS or AMQP, or we might have some SOAP-based services that we need to deal with, or proprietary APIs of various kinds that come up. In short, we don't want to have our mobile app have to deal with this plethora of technology, so the API gateway is the element in our architecture that translates from these different protocols. Now, the API gateway does not need to be the only component in your architecture that does protocol translation. We could decide to build REST capability into our existing services if it's practical. So if we had existing web services, we could decide to put a REST endpoint on it as well. Or we could build some simple adapters like you see illustrated here. The adapters would simply take the HTTP content in and would turn around and call JMS. The main point is we need to look at our options for protocol translation. Now, I wish I could tell you that there was something built into Spring Cloud or Zuul to make this automatic, but the reality is that this is something that you need to look at on a case-by-case basis when it comes up. But don't lose heart, because Spring does have a number of useful tools for working with various technologies. That's what it shines at. So if I need to work with JMS, for example, I have the JMS template that can be used to really easily send a message and even wait for an asynchronous response to be returned. Need to talk to AMQP? Well, we have the AMQP template. Need to call a SOAP web service? There is the web service template. You can take a look at the Spring reference documentation for each of these to learn more about them if you have not used them before. Now, probably the most universally useful technology you can use for protocol translation is Spring Integration. Spring Integration is a sub-project in the Spring family of projects, and it deals with implementing enterprise integration patterns via in-memory messaging patterns. And actually what we're doing here is enterprise integration. If you've never used Spring Integration before, this is something that you absolutely must look at if you're going to be dealing with this protocol translation issue as I've laid it out. Spring Integration provides built-in adapter components and gateway components for, well, all of the items that you see listed here. I'm not going to read them all. So if you think you're going to be dealing with a lot of dissimilar technologies and converting payloads to and from any of these forms, this is your technology. Spring Integration is, unfortunately, it's notoriously difficult to explain, and ultimately, since it's out of scope for this course, I'm going to need to refer you to other resources. But to put it briefly, Spring Integration allows us to build an in-memory messaging system within any Spring application context, including our API gateway here. Within our messaging system, we can assemble pre-built enterprise integration components that perform specific predefined functions on what we call messages. Now, an example of a message might be when the client of our gateway sends us a GET REST request for some information on a product or the team or anything our application deals with. We would use a Spring Integration component called a gateway to receive the request and send it through message channels to an outbound gateway for JMS or AMQP or some asynchronous technology. Spring Integration hooks into the backend technology and handles associating the returned message with the original request, which we would then send via other message channels back to the original gateway. Now, the advantage of using Spring Integration, other than the fact that we don't have to write code for the various technologies we integrate with, is that we start thinking in terms of messages and payloads going in and out. And when we are writing an API gateway, this is what we really need to think about: receiving messages, sending out messages, combining return messages, and so on. So now hopefully you had a good lesson on what the API gateway pattern is all about. We've learned that it is an adapter built specifically for the client that lives on the server side to make it so the client has a nice clean interface to deal with and does not have to deal with the different services directly. We saw that Zool is an easy-to-use technology for setting up routing and making the bulk of our gateway, but we also saw that we have to think about things like caching and resource expansion and protocol conversion, and that the mechanisms for doing these are quite varied. So now that we have these concepts in place, let's take a look at an exercise. This exercise is actually quite simple. We will utilize Zool to set up a simple proxy server. You will also have the opportunity to set up a simple e-tag filter to see how it works. I think you'll find this exercise well worth your time.